-25 രൂപ പറഞ്ഞോടാ. കുറത്തന്നെ പറഞ്ഞു. ഹലോ ഹലോ, ഇതിപ്പോൾ എൻ്റെ സൗണ്ട് പറഞ്ഞു.
ഇത് മാറ്റി കൊടുക്കണം.
ഹലോ
ഓഡിയോ അല്ല അല്ല, ഇതിൻ്റെ സിസ്റ്റം മാറ്റി കൊടുക്കണം. ഇതിൻ്റെ ഓഡിയോ ഇപ്പോൾ ഇതിലേക്ക് ആക്കി കൊടുക്കണം, ബ്ലാക്ക് മാജിക് ആക്കി കൊടുക്കണം.
ഓഡിയോ ഇൻപുട്ട്
അതല്ലടാ, ഇൻപുട്ട് മാറ്റി കൊടുക്കണം. ക്ലോസ് ചെയ്ത് ഇതെവിടെ അല്ലല്ലോ, ഇതിൻ്റെ ഇത് ഇവിടെ എനിക്ക് വയ്ക്കാം. വേണ്ട ഈ മൂന്നത്ത് പ്രോപ്പർട്ടീസ്. ബ്ലാക്ക് മാജിക് ആക്കി കൊടുക്കണം. ഇപ്പോൾ ഇതിൻ്റെ സൗണ്ടാണ് വരുന്നത്. ഇപ്പോൾ
അല്ല, ഇപ്പം നീ വർത്തമാനം പറഞ്ഞേ.
ഞാൻ വർത്തമാനം
ഒന്നും കേൾക്കില്ല. അത് നമുക്ക് ഇവിടേക്കുള്ള ഔട്ടുള്ളൂ അല്ലേ.
പ്രോപ്പർട്ടീസ് എടുക്കണ്ടേ? പ്രോപ്പർട്ടീസ് അതല്ല,
ഹലോ ചെക്ക്.
ഓക്കെ അതാണ് പ്രശ്നം. ഇതിന്
ഹലോ ചെക്ക്. ഹലോ ഓക്കെ. ലാപ്ടോപ്പ് ഓഫീസിലേക്കല്ലേ?
Good afternoon, everyone. I think I'm the next person to present, but I'm starting today's afternoon session. I know everybody is tired or maybe having lunch, so I'll try to make it interesting. So this is the topic, or this is a paper we are presenting on this conference: Artificial Intelligence for Optimal Departure Time Recommendations in Sustainable Flight Operations. So the team members include myself, Dr. Hanna Ali, Professor Sindoge, and Hussein and Doran. So this is an overview of my presentation. It starts with an introduction, then briefly discuss about what problem statement, then objectives, data collection and preparation, how we carried out, exploratory data analysis, what the activities we carried out to find out features and other thing, then methodology we adapted for this research. Finally, result and discussion, conclusion. So I'll start with the challenges in optimizing departure. I think most of us have traveled once upon a time in airline, started your journey, you may be continuing that. So always you experience some delays in your flight. When you are as a traveler, you may be thinking whether your departure will be on time, your arrival will be on time at destination. These are the things worrying for you. So as a pilot, when you travel, start your journey, the pilot also need to understand whether I will be reach on time or delay, subject to his departure. But the thing is that when as a pilot, he can have a control over his flight, but he don't have a control over other flights. So like a busy airport like Heathrow, Dubai, where multiple flights are arriving at same time, even though they are departing from different departure station. So in this study, we are trying to focus about how we can do a predictive analytics or AI application to develop a system which is supportive for pilot or airline operator to understand what is the optimal departure time for them to reach the arrival airport on time or minimizing the air delay. So the complexity on this problem is how a busy airport handle different type of information. Suppose if you consider an airport, it is a collection of different entities working together, where airlines are operating, also where the air traffic controls are applying, and the correspondingly ground operations are managing. So it's a complex place. From there, this prediction is very important how we can handle. And one of the thing, airline point of view, as you plan to travel around 6 months before, you can plan, because airlines are preparing their schedules at least 6 months before their actual travel. So what makes it difference that each day there are a lot of changes will happen. But on the day of operation, all the planning will be not exactly followed as what we are planned. Because if you see, you may be travel from London to here, yesterday somebody may be travel, your planned scheduled traveling time was at 11:55, your flight may be departed at 11:40 or 12:15. So these variations will happen, and these variations are due to multiple reasons. So finding each delay, what is the exact reason, is a cumbersome work. It's a human cannot identify what are the exact reasons. So in our research, we are trying to find out how we can best predict based on what knowledge we have and how this will be impacted in environment. So the problem statement we are deriving from this research was how one flight delay is affecting other flights, or one flight's delays are affected with the other flights, how they are whether they are interdependent or not. And the solution for this is this much large amount of data we are humanly analyzing is very difficult. So we are proposing AI-based system to resolve this issue and provide optimized solution. The goal is to enhance operational efficiency and sustainability by providing AI-driven departure recommendation that consider cumulative impact of concurrent flight operation. What? The solution we are proposing that if one pilot is want to depart, he will be getting an information about what will be his delay at destination airport, subject to the same time window what are aircraft coming on that airport. So that information if you are getting, you can take your decision quickly and you can start your journey on time. So the objective in this study was to evaluate how variation in flight departure timing affect arrival time and congestion, how congestion is happening in the other airport, because if you consider Dubai airport, your Dubai arrivals are from around 60 to 70 departure stations are there. You don't know what's happening in that airports, but your control may be happening on what in Dubai airport. So we need to find any relationship is there and propose a AE system which make use of flight data to predict flight time depending on departure time. And finally, develop an AE based recommendation system that recommending appropriate departure time to minimize delay, fuel consumption and emission, therefore enhancing a overall flight efficiency and sustainability. So the objective of the study is improve operational efficiency and sustainability. Moving to do the research, we needed proper data collection. We started our data collection around 1 year back, where we collected data from different sources, and majority of the data we collected from the flight radar 24. Along with that, we collected additional information. The thing is that in this study, we considered Dubai as a case study, where Dubai is a hub, where it is one of the #1 airports which is handling more number of passengers on an average basis, and it is on traffic insights. If you consider in 2023, Dubai recorded historic high of 416,000, which is reflecting around 21.3 increase in flights. So every year flight number is increasing, associated delays and complications are increasing. So we consider our model can be best suited for Dubai airports. And relevance for AE modeling, because of I told you when traffic volume increases, more number of data is there, it is very difficult to handle human to take decisions on a very small interval of time. And we started our work with the data collection, because the data which we are collecting from sources which is not for our study. So we need to pre-process it, format it and making it to correctly to carry out our study. So that data pre-processing we carried out, and based on that we started analyzing what are the flight operational impact and what are the interdependencies in flight operations. For that, we carried out exploratory data analysis. In exploratory data analysis, we compared what is the different range of flights operating to Dubai, how their flight duration was varied. For we considered different departure station, and these flights were regularly flying as per the schedule to Dubai. And you can see, if this is a box plot where we are representing how the flight duration has varied from different origin. So you can see some of the airport which is very close, we call it as short haul flight, because it may be less than 3-hour flight, where the variability is comparatively less. If you see the long haul flights, that is more than, we consider it as more than 8 hours or 6 hours of journey, we consider as long haul flights. These flights having more variation. And in mid-range flight, the variations are between nominal level, where the variations are occurring in their flight duration. So this shows that different departures, the flights are coming to Dubai, their flying time is varying regularly due to n number of reasons. Some are recorded, some are not recorded for further analysis. Now, because we see that there is a large variation, now we studied about how, whether it is affecting other flight operation. For that, we considered cross correlation map to study how one flight departure delay is affecting other delay. The most of the previous studies were conducted based on how their delays was affected. It's not the studies were not conducted for how one flight delay is affecting other flights. In this, you can see the diagonal lines which shows that there is a very high correlation between departure delay and arrival delay. There are two ways it's dependent. Here you can see the value is going from -1 to +1. There is a positive correlation and negative correlations are there. So from this study, we analyzed that there are flights, their departure time are dependent on other flights. Suppose you may be considering 30 flights on window. On that, if one flight is delayed, the other flight can have a chance of delay. How it will see in practical scenario, suppose you have an airport with 30 aircraft are coming in particular time, suppose it's on 200, there are 30 aircraft are scheduled for that airport to land, Dubai airport. Suppose the first flight will land on the first minute, after that there is a separation required of 1 or 2 minutes for Dubai to land the next flight. So when the flights are coming at same interval, if 2 minutes gap is required for one flight, you can imagine how much delay you experience in air due to same time you are arriving at destination. So one flight is delayed, it is depending on delay on other flights. So this impact we were able to establish due to this study. Now moving forward, we considered how actual versus delay variation, how the delay variation happen for long haul, short haul on different type of aircraft, because when you consider, if you consider from mid-range flights, if it is from India, operating from India or Pakistan, you may be operating Airbus 320 as well as you may be operating Boeing 777. So these flights having different duration and different time delays they are experienced. So we analyzed how departure delays on different time interval, how it is affecting the delay. So you can see the variation is from 0 to 80 minutes. It's a large variation time for a scheduled flight. You cannot imagine if flight is 15 minutes delay, 20 minutes delay. The major problem in practical environment is that suppose you planned for 30 aircraft for 1200 to 1400. Next hour also you plan for 30 aircraft. In the first hour, all flights are delayed. Due to different reasons, they delayed. So the next hour, there will be a congestion at that airport. Due to these delays, everybody will come together and this make a congestion in the airport and aircraft may experience delay. Due to that, the flights may experience a delay. So in this analysis, we found out that there are delay and flying time variation, and we observed that from 800 to 900, the hours of departure, there are large variation happening due to different reasons in the departure airports. So moving forward, how we can use machine learning for this kind of study? We used XGBoost regressor. We carried out analysis on different machine learning models to predict the arrival time, because once you want to apply AE based recommendation system, you should first predict what is the arrival time of other flights based on the data, historical data. In the first step, we carried out the predictive model for arrival time prediction based on departure time. So for this, from our previous work, we recommended for XGBoost regressor to predicting the arrival time. Once you predict the arrival time of all aircraft, you can use reinforcement learning for departure time optimization. I think most of us are learned about reinforced learning. Reinforced learning is a AI technology where the agent it is considered as agent will learn about what is the action for each activity. If it is doing right thing, it will be giving award, other reward, or if it is taking a wrong decision, it will be penalized. We train the model with the data, and each time it has decided whether right decision or wrong decision. Based on that, model is built. It's like unlike a conventional thing, it's not a proper model based thing, it's an agent based modeling in AI. So for that we used Q learning algorithm. So for that we given a reward function. Reward function we decided based on penalty for delays. Suppose the flight if the flight want to depart at 1200, the flight is delayed. That time the prediction model agent has predicted correctly, then we will give a reward. If flight is on time, or if it is early departure, it is identified that this is good for your reaching on time, that time we will be rewarded with the incentive. So this way the agent has learned the activities across the data. From that we build the model. Based on this, we finally concluded whether our model was very good to make the predictions and taking decisions. For this, we consider model performance. Model performance we carried out based on mean absolute error and mean square error. On that, we got for XGBoost performance 5.18 and for RMSE of 6.85 minutes. This indicates that if your flight is, suppose you are departing from London Heathrow, the model is able to predict your arrival time before your departure with an accuracy of 6.85 minutes. So this is the flight time predictability using XGBoost. Once you predicted using XGBoost, you will compare with the other flights what is the arrival time and what is their departure time. Based on that, agent will recommend what is your optimal departure time to reduce your air delay and emission, so that you can arrive on time. For simple example, to understand the concept, suppose you are traveling from here to Abu Dhabi. So you have a departure time. You need to check in Google. You will find out what is your best time to depart. In Google, we don't have the facility. We will check our departure time. Start now, it will show what is arrival time. Suppose tomorrow you have a facility, if I am taking 5 minutes delay, what is my arrival time at Abu Dhabi? If it is able to predict, you can delay your departure 5 minutes to avoid road traffic. So that is the basic concept of this modeling. So for that we used the agent based learning modeling. Now future work we planning on this particular study, because our results are promising, and it can be help the air traffic controllers, aircraft pilots or airport operation to plan their departure, and based on that we are planning to improve the accuracy. On the training we observed that when reinforcement learning is there, when some scenarios are not there, the model is unable to predict properly. So we want to do fine tuning on the modeling approach, and we will be enhancing this facility. And if you consider the scalability, it's a huge potential for future, because future we want more predictable system. For that this modeling approach can be used. To conclude our research, we developed a AI based modeling for optimizing aircraft departure time, focusing on reducing delays at enhancing operational efficiency. So this study is a universal model. When you apply different data, the model will change, but the concept will remain same. So this can be universally tested, and the result supports model potential as a foundation for AI driven recommendation system, because we are using this for prescriptive analytics. This is a future generation predictability. And future work, we are integrate the reinforcement learning to refine departure recommendation. Also we are planning to incorporate graph neural network to improve further accuracy on this model. And I hope that this will be our base work for future work, and I hope you enjoyed my presentation. Thank you all.
Thank you for your presentation. We've got plenty of time for questions, and I spotted you with it before, and you said to say, I hope they ask some really tough questions, because I'm really ready for it.
Yes, sure.
No, yeah.
Yes.
So I understand this model is mainly focused on Dubai. So
Yeah.
it's a hub and spoke model, right?
Yes.
So how would this model work on an airport that's not working on a hub and spoke model?
The concept behind this modeling approach, because most of the AI models are data driven models. Suppose the modeling concept is important, where you are using this type of parameter. Here we identified what are the features to be considered for model. Suppose tomorrow we are tested with the Abu Dhabi airport also, but we didn't include in this study. Another study we included. The model will use this parameter. We identified 5-6 key features which can give a better prediction accuracy. So that's why if you are doing this for Dubai airport, the same we can apply even London Heathrow or in other airports, where the parameters we identified during this research and interdependency are applicable to all airports. Only the airport infrastructure will change, the operation remains same. So that's why this model can be used for other airports. Only when you do the training process, you have to give the new airport data. Suppose you are doing with the Heathrow airport, you need to give the Heathrow airport what is arrival, their departure time. We need to collect the information for that. That all data driven model having this one. Yes.
Can I ask a follow-up, please?
Yes, sure.
So my understanding of, I might be wrong, my understanding of law is like this many hours, so say from 800 to 1000 hours, it would be all incoming, and then we would have an outgoing, right, from 1100 to say 1300.
Correct.
So if in an airport, say for example Delhi airport,
Correct.
and then at the airport, that might not be a hub-based airport.
Correct.
There can be an incoming and also there can be an outgoing.
Correct.
So then also this is fine.
Yes, this model you are based on your departure time. Suppose you are modeling for now tomorrow for Delhi airport, you will consider the all flights departing to Delhi airport. you will collect the delays happen for these flights for past 6 months or 1 year. Then you consider that how much delay this aircraft experienced for that airport, and the model will learn for what the best combination of mathematical model can fit for that airport. Once the model is built, next time this model you developed, you cannot directly apply to Delhi airport. Delhi airport, you need to start new training process, and it will build a scenario based on that, it will develop a model. So that's the basic concept difference. I think you understood.
Yeah.
Yes.
For the training of your model, you use the time of departure and time of arrival.
Yes.
Okay?
Yes.
To, let's say, estimate what is the delay.
Correct.
But during the flight, we have other factors which they can easily affect your travel time.
Correct.
If you have a headwind or tailwind, if you have what is your climb procedure, what is your descent procedure.
Correct.
Means that maybe you have 10 minutes delay
Yes.
from the departure, but you are 5 minutes ahead for the arrival.
Yes. So
Did you consider any factor or any safety
yes.
in your training procedure?
As I worked as a air traffic controller for 10 years, from the experience, suppose you consider for 3 hours of flight, okay, when you have a upwind or downwind, which is less than 3 hour or 2 hour, this variation will be very small. It may be 1 or 2 minutes. Suppose your average speed is, you are considering your average speed, so variation will be very.
At 1-2 minutes, if you have the first aircraft delay for 2 minutes, the second one it is a huge.
Yes. So what I was telling, if you consider that is a delay is there. So in this data, your all delays are incorporated. It is a cumulative delay due to various reasons. Suppose you consider x1 is one delay due to wind effect, x2 is another delay due to some other effect. These effects together we considered as delay happening. So if it is happened due to various reasons, the impact will be the same. Finally, it's a delay, in air delay. So that's why in my box plot I shown you the flights, these flown from x to y with the different speed, different reasons.
That's correct, but it means that maybe today you
Yes.
have that delay,
Yes.
but tomorrow that delay is not there because of the wind.
Yeah, tomorrow it will be very different reason. The time being, there is no such system which is recording what is exact reason for each delay occurrence. So you cannot segregate it into multiple delay classes. If you are that information available, the model will consider that one. Suppose 3 additional information available. Presently, we have only the information what is your departure time, what is your arrival time. So when the delay for this other flight happen, how this is delayed, that interaction we can get. But this flight, how much is happening, you need to go to baseline data, what is the trajectory it followed. So that information in this study we didn't study it, but if you consider the 2 minutes delays in a flight operation environment, that's why first we are using SG boost to predict what is the arrival time. That accuracy we are getting with 5 minutes only. The previous work we reached up to 3 minutes only, we can predict from historical data what is the time it will reach in the destination. So that we are incorporating in the previous model. So it is capturing that information from this data set. Yes, Dr.
But from a decision-making point of view, considering this uncertainty is very important. It means, I believe the model you have chosen is fully data-driven and you cannot quantify uncertainty. Maybe if you, for example, select a kind of probabilistics version of that machine learning method that you have, you can also quantify uncertainty due to these different factors.
Yes. Doctor, one thing I can tell you what the utility. Suppose these data-driven models you cannot use directly for air traffic control. Air traffic control require every seconds of data based on that modeling required. But if you are a flight planner, you want to know how much your experience delay in every delay departure, how much is your cost. Before departure, you should know what is the delay departure. So your operation environment is in planning phase, this is more accurate, because you are not finding the conflict between the aircraft, you are only scheduling what is the best departure time so that I can reduce my delay in the destination. So when you model it for 100 this much data, you understood that this much maximum variation I can observe. In practical environment, these 2 minutes, if you can anticipate 15 minutes delay very well in advance, that is a good achievement, so that you can plan your departure properly. But what you are telling is, when we use this particular model for air traffic environment to decide the sequence, then this model cannot be used directly, because the model applicability which we are planning for air traffic flow management, where we are taking a decision before flight departure, where we need to know what will be the expected arrival time most accurately. So for that, this model is very good. Yes.
Thank you so much, sir, for the presentation. I wanted to know if there is any difference in model between passenger flights and cargo flights.
In this study, there is no difference. Whenever in actual flights also, there is no difference between airport from departure to destination, there is no difference between cargo flight and passenger flight. All flights having their own average flying time, average flight timing, everything, because all depends on its cruise speed. And whenever wind factor is there, suppose you are traveling for 1 hour to one position to another position, you are getting a 10 minutes, 10 kilometer per hour tailwind or headwind. How much gain you will get for this traveling? Maximum 0.3 seconds or 10 seconds or 15 seconds. You will, how much you are varying this one, maximum 1 minute only your variation will be there. So if you are considering for long haul flight, it is important. Short haul flight, all flights are considered in air traffic environment similar category. Based on aircraft type and its speed, the profile will change, but the overall model remains same. Thank you.
If you could join me in thanking our speaker one more time.
Thank you.
Now, what I would like to propose is, because to make us synchronize with the other sessions, what I would like to say is we wait until 10:02 before we have our next presentation, just in case there are other people that want to come and join the session or people want to leave. So if we could wait till 10:02, is that okay with everyone? Yeah. Thank you very much.
You should have told me this in advance, then I should have extended my presentation.
I thought I cut you a break, otherwise we would just go on and on.
Good job.
Thank you.
You have math expression for the error?
That's
Math equation?
yes,
to
yes,
find
yes,
the error,
yes.
Not using tools. For the
I-
basic rules.
1 minute, I will give this mic. Thank you. Can you take my mic? Is my mic is still transmitting? Hear you. My copy though. Okay. The conference are on. And we are going. Okay. Thank you.
I'll keep it here, it's okay. Can I start? Thank you. Thank you so much for joining us today. It's a privilege to present on the 5th International Aviation Management Conference. Good afternoon, everyone. My name is Dr. Rukshanda Kamran. I'll be today discussing about the paper which me and my team has presented, and we are going to be presenting about it. It's about visualizing the airline catering system using AI and machine learning. This was not being able to complete, or we were not being able to complete it without our team. They all bring different expertise to the table. So me, along with Dr. Mustafa, Hayam, and Dr. Zainab, we have accomplished this task successfully. The project overview is what this whole project is all about, that we wanted to discuss, we wanted to show or create awareness about how much food has been wasted in airline aviation food catering system, because the system which we have till today is not about predictively analyzing that which food is going to be useful for that particular route, or what is the criteria of picking up the dishes or defining it. And how much food is being wasted till today is more than what has been done, or whatever we have completed so far is not efficient enough. So the project introduction is, the aviation industry is facing challenges due to high volume of food waste from under-eaten or pre-defined portions. So we already have a predefined portion. So people, whoever is in the catering business, they even don't know that how much food they have to serve in that particular route and how much they have to use it so that they can use it for other route, or maybe that route is not suitable for that particular food. So how they are going to take the measurement, or what techniques they should use in order to predict it. According to IATA 2023, airline transportation issues a lead to environmental damage and economics. And we have seen that around 2015, people have given some of the research where they have shown that the current state of prediction is not good enough to predict. So the project background is, we want to go for global food waste crisis. We want to discuss about airline sustainability challenges. We want to discuss about financial impacts of it. And further, we want to discuss about advancement of the technology. And then we will need to discuss about data-driven solution, because we have gathered a lot of data is already available with the industry, and then how we can use it in order to predict right amount of food for right amount of. Then the problem statement, that according to food waste in airline industry, especially for the airline catering, 5.7 million ton of the carbon waste is generated annually by 2023. Airlines serve millions of meals each year, with 20 to 30% of the prepared meal ending up as a waste. And according to 2.3 billion global waste per year. We have three objectives of this particular problem, that how we are going to reduce the food waste, and how we are going to automate the accuracy, and how we are going to improve the sustainability into it. Further, we want to explore how we can enhance the operational efficiency of the system. For that, we conducted literature review, and then we find it out that these studies has been done, and most of them were being studied in a theoretical framework, or some have used AI, but then none of them have implemented it on a ground scale, and none of them has shown the real statistics. quantify the problem, we have used the methodology and the tools. So we have collected the data, we have done the image automations, we have proposed the model selection, we have done data augmentation, we have done modeling, and then we have deployed them on a cloud environment. We have captured the images and then real-time processing, and then we predicted, and then we have generated the report and analysis to that. The tools and the platforms which we have used were Google, Vertex AI, Microsoft Azure, ASP.NET, Azure Web Job, and then we have used Microsoft Azure SQL Server. So these were the tools which we have used where we have deployed our model. This is our proposed model. In proposed model, we have used 3 layers. First is front end layer, then we have middle layer, and then we had the back end layer. In back end layer, we are having SQL Server database. Then we are having 3 layers, which is in the middle layer, where we were processing the data which we have received from the airlines. And then the first one was the front end layer, where we have provided a simple to use interface where you can upload the data, and then based on the routes and everything, it's going to finalize that which food is going to be more appropriate for that particular route. Then when it comes to implementation, we have done front-end deployment, then we have done image capturing, then we have data storage, then we have done the back-end integration and mobile prediction and other stages. This is our front-end model, which we were discussing the front end. So it's going to be, you are going to log into the system, you are going to enter the username and password, and then you are going to upload the images, and based on the images, it's going to fetch the data, and it's going to show that, okay, this food is going to be more appropriate for this particular route based on the data which we have received from the different places. And now I'm going to invite Khayyam to come and explain the demo of the project.
Yes. So hi everyone, sorry for loading this site and everything. So let me just go quickly and present you guys with a quick demo like what we have made. So this is the portal which we hosted on Azure Cloud, and the purpose of this particular portal is to help the end users to identify like which routes or which different kind of food items are, how much they are getting consumed, right? So first of all, let me just give you a quick introduction for the dashboard, that what is on the dashboard. So if you see on the dashboard, we have, once we log into the system, we have some basic cards there, right? And in these cards, we can see like total food wastage over the period of like last 6 months, right? So the total food wastage over the period of last 6 months was 29,450 kilograms, right? And then we see like average waste per flight. So how much food is getting waste on average flight on each meal, for example, each meal type, for the breakfast, for the dinner, or for the lunch, or for any other irregular meal type. Then we have average cost of wastage per flight in dirhams, in AED, how much the cost is getting accumulated over each food wastage which is happening. Then we have some other metrics also, like total food wastage per route. So we have 10 routes here, and these routes are here in the table, and we are also working to go into more detail for each route, with some of the development is still in progress. But the key metrics are here, which we can demonstrate and we can show. Then we have average wastage per flight. So we have overall wastage per route, we have average wastage of food per flight, and then we have wastage by food category. So the food category here is like breakfast, lunch, dinner, and any other category. So these categories could be snacks, these categories could be brunches or any irregular meals which we are serving on the flights. Then we have average wastage cost per flight. So for each of the different routes, what is the wastage happening and how much it is costing us. Then we have wastage reduction over time, means based on these studies, like how much we have improved so far, means if these studies are applied properly, means how much wastage we have saved. Then top 5 routes with highest wastage, and then we have meal type distributions. So as you all are here, whoever is sitting here, I believe they are not lay person, they all are very, very intellectual person. And we know like this data is actually dumped into the SQL server, right, which is the repository, which is the backend database. And these few charts are developed out of that, but many more charts or many more metrics can be developed. So these are just developed to show you guys like what kind of data we can fetch from the repository once it is properly interfere, right? It's properly detected by the AI model. So how we are actually configuring this is, again, there will be actually 2 systems. So the first one is this one, which a normal person will be using, or a person in the administration department will be using. But the other system will be where we will be training our TensorFlow Lite model through Google Vertex AI, and then we will be mapping that model for a particular tray to the particular route. So I will show you that. So first of all, we have a route setup. So in the route setup, what we are doing is, we are defining the route, our descriptive name. For example, if the flight is going from DXB to, let's say, Karachi, we will put that. Then we will choose the TensorFlow Lite model, which we have already trained with the Google Vertex AI. We will upload that, and we will upload that to the route setup. Once the route setup is done, we will have a descriptive picture for that. We will have the TensorFlow model attached with that. And then these models can be used to predict when the pictures of the leftover food trays or the leftover food items are uploaded into the system. So each picture will be detected against the trained model, and then the system will detect how much food was served and how much food is actually left on the tray. And then based on those findings, we will see in the dashboard and in the reports like how much is the food wastage is actually. So that is actually the short demo.
Yeah, from here. Okay, so we have demonstrated the system, that how the system is going to be picked, how we are going to pick up in the model. So it's not just the prediction, we are doing a real-time system where it is going to be taking the data, and we are working on it. Further, we are going to enhance the system in order to go and explore more and more into it. So that was the demonstration of the system. The results and findings, so these are the results and the findings. So modern accuracy is around 92.5. We have precision, we have recall, we have got average, total training data set size, training evolution time was for 1 hour and 24 minutes. And then prediction time was in 1 second, so it's going to predict it in 1 second. So these were some of the parameters we have used in order to evaluate our system to see that how good we are or where we are standing. Then individual label items, so we have just today, just for the testing purpose, because it's not a complete full-fledged purpose, so we have just picked up some labels. So we have given full is going to be 0.94, half is going to be 0.918, and quarter is going to be 0.89. So we have got some dishes from different labels. So first label is pasta, then biryani, and then green salad. So we have picked up only these three, and we have tasted on this. Later on, once we are going to get the system is giving the results what we are looking for, then we are going to keep adding more and more elements into it. So the conclusion is this kind of system is going to bring a revolution in catering in the airline industry, and this is going to be a kind of an effort where UAE is working on bringing the sustainability and food economics in UAE. So giving this kind of systems or using this kind of systems, we can achieve the goal and we can target it. These are the references, and thank you. Any questions?
Thank you very much. And we're going to have some questions. Yes, over there.
Yes, please.
Thank you for the presentation. I'm not sure if this research also included which geographies have more food wastage percentages. Does this research also cover the geography?
Not at a time being, because we are having a limited data sets. We were working on only a small data sets, and we wanted to see that either the research direction where we are working on is going to be ending up in any fruitful results or not. So once we started working on it, now yes, these all things, as Khayyam has also said, we are working on extending this project. We want to include more routes, more geographic, because the food maybe in one geographic is wasted, other geographical places it's not wasted. So we have to see all those things. Once our database, the SQL is going to be, have lots of data in it, then only we can play around with this all information. But for the time being, as we were having limited data, which was available for free for different resources, so we were playing with that data only. Yes, these all things, these all parameters are going to be extended in this project. So this is just the beginning. So we wanted to put this as a good project, a working project in front of the management.
So who will be like your target source for the data? Airline companies or airports or catering companies?
Usually ideally it should be airlines, because at the end, companies, we don't see that much of the companies are outsourcing, or airline are outsourcing any of the companies. They are basically built in one. For example, Emirates also, they have their own building catering system. So we are not targeting like third party, we are targeting the airline itself should provide us the data so that we can use the data in our system and we can improve our results. So that's the ideal situation. Let's see how we are going to be successful in doing it, because that's the ideal scenario.
Thank you so much.
We have one more question. No, I think your hand up first.
Thank you.
Yeah, my question is like, I think it's not, this is not actually a question, because I was thinking when I'm seeing your presentation, like, okay, this one is very underrated in a regulatory landscape, because they have different kind of ways to reduce emissions. And I think the systems like have the full potential to be used to reduce the weight of the flight. And reducing the weight of the flight meaning less emissions, less
Yep.
burn, less fuel burn, and then less emissions. Do you think your system or the system that you develop have potential to do that?
Of
And
course, see, once you implement one system, it's not going to be targeting only one point at a time. There are going to be some things, some branches, which is going to be, helping it out. For the time being, it's a vast topic. So we cannot say that, yes, in which direction it's going to help and how it's going to help. Yes, what you are saying, we can explore that area also, that how if the food is going to be managed in such a way that only a limited amount of food or required food is going to be there, then definitely not in a direct way, maybe indirect way, it's going to help in that area as well.
do you think the potential is big?
Of course. Once we are going to launch something, we are not saying that this is 100% like perfect, but we are working on this direction. So hopefully the end result is going to be able to address some other challenges, not in a direct way, maybe indirect way. Thank you so much. Yes, sir. Easy one.
Easy question, sir. In this modeling, we used machine learning to predict. So, as per flight traveling, the passenger will change each flight.
Yeah.
And there is these are two connected questions. And second one is that you are capturing image and you are quantifying.
Yeah.
So, while delivering, we can get the correct picture. But when the food is wasted, the people will have a different way of taking their food. So, how the model is able to capture what quantity of food is remaining from the modeling perspective? What was the prediction?
Yes, so I would like to take this question. So, what we did is we trained the model with Google Vertex AI, and in this Google Vertex AI, they have several models, right? They have image detection model, they have audio detection model, they have video detection model. I'm not going into those things, but I'm just giving you, the kind of facilities it has. So the image detection model, we can train a supervised model, and in the supervised model, what we do is we just label first, right? For example, cat, dog, or whatever different items, and then based on those items, we upload or we train the model based on those pictures, right? Different angles, different colors, we make the model. So in this approach, what we did is, so for example, let's take a dish as pasta, right? And we took a dish as a pasta, and then we labeled it full plate, and we took a lot of pictures of the pasta from different angles, from different serving patterns, and on different even dish colors, right? Then what we did is we took 75% or 25% off from the plate, and we again took a lot of pictures from different angles, from different lighting conditions and all those things, and we labeled that as means 75% left, 25% consumed, right? And then we did the same thing with the slabs, like 50% and 25%. So each dish which we are training against is that dish is labeled against 4 different quantities. So 100%, 75%, 50% and 25%. So based on those different labels, then the system is actually detecting how much food is left on the plate, right? Or in a cumulative sense, how much food is left on a tray. So with each of the food, we are labeling it with the supervised model with the help of Google Vertex AI in 4 different quantities. So this is the method or methodology which we are using to train the model. Have I answered your question? I'm just trying to give as fast as possible I can.
I think in the interest of time, if we can move on to the next speaker, we start to cut it short.
Yeah.
Okay. If we can thank our speakers again one last time.
Thank you. Thanks.
I was just imagining pasta 75%. To our last speaker of the day, Dr. Danishwar from Emirates Aviation University. And the floor is yours whenever you're ready.
Hello everyone, thanks.
Hello everyone. I'm going to show you how we can use Bayesian network as a powerful machine learning method to develop a risk assessment methodology for the road traffic and possibly for aviation risk analysis. And why I have used Bayesian network over other machine learning method, because Bayesian network could capture uncertainty and at the same time is very useful to model complex dependency between different risk factors. And more importantly, Bayesian network is very useful when we have a limited data, particularly for the accident in the airport, which the data are very scarce. This is work done by Dr. Elham Toloui, assistant professor of aerospace engineering at the Faculty of Engineering here, and also Professor Zin, director of research, and Dr. Tabassum Siddiqui from Anglia Ruskin University in UK. I'm going to start with highlighting challenges in airport road traffic safety, and then highlight the possible risk factor, and then move to a road the road traffic accident, or RTA. Transportation safety in airport is very important, and at the same time is very challenging, because there are several players involved. It's involved with the aircraft movement, people and vehicle, and also environment. So there are several factors interacting to each other, and therefore it makes it quite challenging. And in order to develop a proper and robust risk assessment, we need to simultaneously consider the impact of all of these players together. And most of the study focus on the accident associated with one of these, rather than taking into account all of these factors together. Recent study published in Digital Transportation and Safety, just 2024, highlight the possible risk factor in the airport. It's from a driver, a pedestrian, and vehicle management and airport road. So we could, for example, say a driver fatigue, or a pedestrian in the blind state, vehicle movement, and so on. Therefore, you can see it's quite challenging to consider all of these in order to develop a proper risk assessment methodology. So unfortunately, I didn't have access to the data due to the confidentiality, and also even if the data is available, they are very scarce. Therefore, I have moved to the RTA actually case study. But before introducing the methodology on the RTA datasets, I'm just going to highlight that why Bayesian network is important. Bayesian network is important, as I mentioned, that we can capture complex dependency between a wide range of the variables. In particular, when we have a limited data, because the structure and the model can be trained by integrating expert opinion, and at the same time it's very useful for decision making, because we can provide visual tool to the decision maker and tell them, for example, what's happening, what factors affecting other factors, and also we can add for example, cause or decision nodes to the models and make it a proper decision-making tool. And more importantly, it's probabilistics, means it's trained based on the Bayes rule. Therefore, at the same time, in addition that we have prediction, we can actually provide uncertainty for our prediction, which is very important in decision making. It's not fully, and I have to emphasize that here we don't have abundance of the data that we can use other data-driven approach. So we have a limited data set. So I moved to the road traffic accident. The main motivation was when I was in the UK, that there was some kind of debate whether digital highway is effective or not. Therefore, we wanted to verify whether digital highway is important. Therefore, we collected data on the 2018, and we wanted to compare with the 2010 that to see whether it was important. And most importantly, we wanted to address this question: what are the probable cause of injuries and fatalities from road traffic? And we can do the same and adopt it to the aviation accident. We believe there has been a lot of improvement in the road infrastructure, and we expect that the road accident should be increased, but this is not reality. Just in the decades 2010 to 2021, just before the pandemic, we only see 5% decrease in the road accident, which is not encouraging. And we see an increase just after the pandemic, 9% actually road accident. And the research shows that we are far behind of the target set by the UN to decrease accident by 2030. So here I'm going to introduce briefly the UK RTA case study. That's the data from 2018. As I mentioned, over 160K number of the people suffer from injuries and all other severity. And most of the people actually suffer from involved in these accidents are between 5 to 29 years. And results of that, almost 1,800 people died in car accident, and 3% globally spends from GDP actually due to this road accident. So the data that we have are 3 data sets. One data set regarding accident circumstances, almost 122,000 observation and 32 features. Vehicle, that's all features about the vehicles involved, and casualty. So in total, we had 32 variables from accident circumstances including environment, road, weather, etc. All the features. It's amazing, in the UK for any car accident you can have over 500 variables. Just we focus on 3 data sets, and fortunately we don't have that much casualty, but still and 23 features vehicle and 16 features for casualty. So, for example, we have done extensive exploratory analysis just here, for example, some spatial analysis of the geographical, and you can see Midlands and close to London has the highest car accident. We did some clustering, density-based spatial clustering of the accident based on the 0.5 radius and minimum of 18 accidents per each cluster, and you can see again close to the London has the high too many clusters, and then West Midland, and here some of the cities with highest accident: Birmingham highest, 3 region in London, second to fourth, and also just we bring Coventry because the research originated from Coventry University. And you can see here a heat map of the region with the highest accident and lowest accident. So key trend and correlation in the data sets, for example, a significant decrease around December and a spike in June, the exploratory data analysis that we did. Most accidents between 8 to 9 and 3 to 6, mostly rush hour. September had the highest fatality rate and February the lowest. Friday saw the most accident, especially between 1 to 3 p.m. and 68% of the accident occur with the road with 30 miles per hour speed limit, which is interesting. And people between 26 to 35 were the most affected in car accident. So we started to see how we can find the most affecting features from all of these features from 3 data sets. We started with correlation. Correlation gave us some insight. For example, for the accident data sets, we saw a very strong correlation between a speed limit and urban and rural features. For the casualty data sets, we realized there is a strong correlation among pedestrian location and also pedestrian movement, pedestrian road maintenance, worker, and also a casualty class. The same for the vehicle data sets, we did the same, and there is a strong correlation between engine capacity and propulsion code and also vehicle type. But usually correlation, we assume the relationship between all of these features are linear, which is not true. Therefore, we did some other feature selection, proper machine learning based on the BORTA. And before that, we did some pre-processing on dealing with the missing value using a random forest imputation technique. And finally, some of the variables that were very important in our risk assessment as a target variable, we realized there is a huge class imbalance which we resolved through a smooth kind of oversampling technique. And finally, this is the list of the 24 most important features after we combine all these 3 data sets together. And now we want to see how we can use these 24 data sets to develop our Bayesian network-based risk assessment. Just briefly introduce what is Bayesian network. Bayesian network provides you with the directed cyclic graph, or known as a DAG, that shows the relationship between these variables in a cause and effect relationship. The models is trained based on the conditional probability rather than correlation. And the full models can be decomposed in terms of this a local distribution, and local distribution is associated with the parent node. For example, payment is dependent on the income and deposit and so on. And if I know the payment, income, and security are independent of each other, that's very simply, it's called conditional probability. And after we train the structure, we can compute a conditional probability on each node, which if all of our nodes are categorical, that conditional probability is just conditional probability tables like this. And then we can actually verify different scenarios. For example, in causality, we say, what if I know the payment is at state 2? If I know the payment is this value, how that might affect the other variables. So we can update models automatically through Bayes' rule. Therefore, it's proper cause and effect analysis. If we want to do proper cause and effect or causality analysis, Bayesian network is the most widely used tools. And also, as I mentioned, it will be used for the decision making. We can add some utility nodes as a cost or any other loss function, or we can add some nodes, decision nodes of interest. And you can see even any people with the limited data science background can actually understand what's happening here. So that's why it's widely used for risk assessment and decision making. This is the Bayesian network structure learned from 2018 data sets. Sorry, it's not very clear, but here casualty severity I consider as a target variables, or as variables that actually highlight, or it's very important for me. And you can see how these variables are affecting each other. Then, for example, you can start computing probabilities given different variables that you want. For example, original probability distribution of the severity, casualty severity for the seriously injured or slightly injured and fatal was this. After I learned more about other factors affecting fatality, this probability starts to update it based on the additional information I have provided. All of this updated based on the just Bayes rule. Therefore, it can be used for the just before conclusion, as I mentioned, Bayesian network-based risk assessment effectively analyze a risk factor, and we can include all the factors affecting accidents simultaneously. It provides us a proper probabilistic risk assessment, and we can use it for scenario modeling. And for example, here it's just how we can extend Bayesian network to analyze airport road traffic. I think the original things is to develop accident tree to find out what factors affecting that. I have already highlighted factors affecting accident in the airport, and then we can actually build our Bayesian network, and at the end here is where we can actually use it for risk assessment in the aviation transportation. We have done the same. That's some additional scenario modeling that we did for the 2018. And sorry, this one is the Bayesian network that we have built for the 2010. And you can see the casualty severity is here, and the factors affecting that before having digital highway in place is completely different, and the probabilities that we had is completely different to the 2018 when we had a digital highway actually running in the UK. Finally, this is, for example, another Bayesian network that I developed for the inpatient mortality due to the COVID-19. It was, for example, we had 42 variables after feature selection and finding the variables affecting inpatient mortality. We realized these variables affecting our target variable. Then I trained it fully based on the data. Then expert says, no, we are not happy with this structure. This structure should be like that. I updated based on the expert opinion, and finally, this is the final model. That's it.
Thank you very much.
Thank you.
I know we're kind of out of time, so if you have any questions, you can speak to others afterwards. I appreciate it. Thank you, everyone. Thank you, our speakers, and thank you.
Thank you. It's on. Thank you. Oh. Thank you.
कौन बाकी हाँ खत्म हो गया स्लाइड है ऊपर कौन अभी कौन बाकी है सिग्नल उधर क्यों होगा ना कौन सा स्विच चाहिए उसको आपको अभी जाओ उधर वेट कर रहे फ्रंट में जाओ गाड़ी रोड में नहीं वो गेट नहीं हमारा एंट्रेंस का कल देखेगा हाँ शाम को